8.7 functions defined by equations. So in 8.6, when we were creating graphs of functions, I discussed how we have notation, function notation. So this is arrow notation and this is function notation. So this is just P of n. N is going to be the variable. It's going to be our input, and then P of n, or we see P of n, is going to be our output. This is our independent variable. This is our dependent. This is our domain. This is our range. So when we see g of 2 equals 6, we're plugging in 2. That would be our x value. This would be our y value, or our g of x, g of n, etc. So g of 2 is not a product, so we're not multiplying g times 2. This is all it is saying in the function g we're inputting 2. Okay, so we'll sort of get the handle of this a little bit. They still look like linear equations. We still may graph them. This is our domain, so these are all our inputs. We're inputting it into this equation, x squared minus x minus 6. And then, so this is our domain, our inputs. We're inputting these values. And then we're going to get outputs. So 0, -4, -6, -6, -4. And so our outputs, our range, is going to be 0, -4, 6. Notice we don't double up the output. So if -4 happens twice, we still just list it once. All right. And I think it says that in there. Yeah, only once. So we would only list it one time. So let's start off. This is going to be arrow notation. So really what this says, let's change that depth of the pen. G of x equals 2x plus 1. When we're going to input the values, x, we're going to input -1, 0, and 1 into the equation 2x plus 1, and then we will get an output. No, that's not the proper. We're going to get an output of g of x. So find the range. So we'll do it. We'll just show what that notation. That's going to be -1. That's 2 times 0 plus 1, which is 1. That's 2 times 1 plus 1, which is 3. So the range in solution set notation is -1, 1, and 3. Now that just happened to be the order, but as you noticed, we put those values, those ranges, in numerical order. This is D for the domain. This is R for the range. D are our X inputs. Range are our Y outputs. You'll hear me say that. I'll refer it to Y, etc. So we'll just write this. F of x equals 3x minus 2. And I don't mind doing a chart. It's just a little bit easier. 3x minus 2. And this is going to be f of x. We're going to plug in 1, 2, and 3. So 3 times 1 minus 2 is 1. 3 times 2 minus 2 is going to be 4. 3 times 3 minus 2 is going to give us 7. So our range is going to be 1, 4, and 7. So everybody gets intimidated by functions, but as you see, we'll do it in a different way. I'll show you another way. So h of x, we're going to write it in function notation. I just like function notation. To me, it's more realistic. Arrow notation, yeah, maybe you see it once in a while. So what we're going to do is we're going to say, hey, what's h of -2? So 1 minus 4 times -2. So we're going to insert this x value, and we're going to notate it here. So h of -2 equals 1 plus 8. H of -2 equals 9. So that's another way we can do this, showing it and I guess detailing our work. H of 0 equals 1 minus 4 times 0. h of 0 equals 1 minus 0, h of 0 equals 1, and then we'll do h of 2 equals 1 minus 4 times 2, h of 2 equals 1 minus 8, h of 2 simplifies to negative 7. So my range is going to be negative 7, 1, and 9. So not the order that I did them, but the numerical order. That's not a great labeled 7. Does that look better? There we go. All right. We'll continue. We'll do that one. Now it's in function notation. H of negative 3 equals 3 times negative 3 plus 1. H of negative 3 equals, we'll say negative 8. We'll simplify it a little bit, that step. H of 0 equals 3 times 0 plus 1. So h of 0 equals positive 1. H of 1 equals 3 times 1 plus 1. H of 1 equals 4. So the range is equivalent to 4, 1, negative, that was not numerical order, sorry, negative 8, 1, and 4. Did I make a mistake on the one before? No, I did it right. Okay. Here we're back to, and we can have, that's what the notation looks like. G of A equals 3A minus 2. So G of negative 2 equals 3 times negative 2 minus 2, and we'll even do it in this way. That's negative 6 minus 2, which is negative 8. G of 0 equals 3 times 0 minus 2, which equals 0 minus 2, which equals negative 2. We have G of 2 equals 3 times 2 minus 2, which is 6 minus 2, which equals 4. So my range equals negative 8, negative 2, 4. Another way of notating it. Not a bad technique. But just showing your function variable can be a capital letter also is really what I wanted everybody to see. We already have that equation, so it's not necessary for me. Let's start plugging in values. 2 minus 4 times negative 1, which is 2 plus 4, which equals 6. F of 0 equals 2 minus 4 times 0, which is 2 minus 0, which is 2. And f of 1 equals 2 minus 4 times 1, which is 2 minus 4, which equals negative 2. My range is going to be negative 2 to 6. Yep. Keep it rolling. Negative 1 equals 5 times negative 1 minus 4, which is negative 5 minus 4, which is negative 9. F of 0, not 0, f of 2 equals 5 times 2 minus 4, 10 minus 4, which is 6. F of 3 equals 5 times 3 minus 4, 15 minus 4 is 11. R for range equals negative 9, 6, 11. Let's see where they go here. All right. Q of n, so Q of 0 equals 4 times 0 minus 3, which equals negative 3. Q of 2 equals 4 times 2 minus 3, which equals 5. Q of 3 equals 4 times 3 minus 3, which would be 3 times 3, which is 9, because we're subtracting one of the 3. So R equals negative 3, 5, 9. Oh, okay, so we can get a little crazier with our formulas. and the proper notation, we need parentheses here. You must have parentheses because you want the base of this exponent to include the -1. If we don't have these parentheses, you're only squaring 1. So important. So that's 1 plus 2, which equals 3. P of 0 equals 0 squared minus 2 times 0 equals 0 minus 0, which equals 0. P of 1 is 1 squared minus 2 times 1. And the reason why we have parentheses here is because we're showing multiplication. The reason why I don't need parentheses here is because there's no negative sign to include, to show the inclusion. So that's 1 minus 2, which is -1. Very important, what would we call it? It's a distinction, very important distinction. That's a place where a lot of students will make notational errors, and then they'll get lucky by not doing it, but because of their lack of understanding of the problem, they will end up doing it correctly, but that is by accident. So b squared minus b minus 2. So the domain is -1, 0, and 2. So we will say h of -1 equals the quantity -1 squared minus the quantity of -1 minus 2, which equals 1 plus 1 minus 2, which gives us 0. H of 0 equals 0 squared minus 0 minus 2, which gives us 0 minus 0 minus 2, which is -2. H of 2 equals 2 squared minus 2 minus 2, which is 4 minus 2 minus 2, which equals 0 again. Oh, yes. So range equals 0. No, range equals -2 and 0. We wouldn't write 0 twice. We don't have to write multiple ranges when they're the same number. G of x equals x squared plus 3x minus 4. So g of -1 equals the quantity -1 squared plus 3 times the quantity of -1, or 3 times -1. It's really not a quantity right there. That's going to be 1 minus 3 minus 4, which is -6. G of 2 equals 2 squared plus 3 times 2 minus 4, which is 4, plus 6 minus 4, which gives you 6. G of 4 gives us 4 squared plus 3 times 4 minus 4, which is 16 plus 12 minus 4, which is 24. I think that's 24. That's 28, 24. Yeah. So my range values go from -6, 6, and 24. How are you going to change it up? How are you going to make it harder? Algebra 1. I'm going to, again, just because I like writing it in function notation, f of -2 equals the quantity of -2 squared minus the opposite, or minus -2 minus 6. That can be read as the opposite of x, the opposite of x. That is 4 plus 4 minus 6, which is 2. F of 0 is 0 squared minus 0 minus 6. 0 minus 0 minus 6 equals -6. F of 3 is 3 squared minus 3 minus 6, which is 9 minus 3 minus 6, which is 0. My range is going to be -6, 0, and 2. Not making it any more challenging. Okay, we're okay with that. quantity -1 cubed. Maybe if you think that cubing is making it harder, squaring plus 2 times -1. -1 cubed is -1. -1 squared is +1. 2 times -1 is -2. And that gives us -2. F of 0 equals 0 cubed plus 0 squared plus 2 times 0, which is 0 plus 0 plus 0, which is 0. F of 1 equals 1 cubed plus 1 squared plus 2 times 1. 1 cubed is 1, 1 squared is 1, 2 times 1 is 2, which gives us 4. -2, 0, and 4. I do like functions. Functions are good. But this isn't really getting it too crazy. 0 cubed minus 2 times 0 squared plus 3 times 0. Okay, I'm going to do it downwards. So that 0 cubed is 0 minus 2 times 0 squared is 0 plus 3 times 0 is 0. We're going to do this multiplication. So it is 0 plus 0 plus 0, which is 0. So n of 0 equals 0. That doesn't look like a 0. That looks like a 6. N of 2 equals 2 cubed minus 2 times 2 squared plus 3 times 2. So that equals 8 minus 2 times 4 plus 6, which equals 8. We have to do this multiplication. Don't do 8 minus 2. Students will make that mistake. Minus 8 plus 6, which equals 6. So n of 2 equals 6. Let's do n of 3 equals 3 cubed minus 2 times 3 squared plus 3 times 3, which equals 27 minus 2 times 9 plus 9, which equals 27 minus 18 plus 9, which equals 18. I think that equals 18. N of 3 equals 18. Does that make sense? That is, yep, that's good. So if I'm going to draw my solution set, I have R equals, and my two values, 0, 6, and 18. All right, thank you for changing. Did they really change it up? They're just showing how you want to input what your domain is. They just have specific domains. So this is inserting, this is x equals 2, x equals -3, x equals 4. So we're plugging in these values in for x in where we see x. So when we see f of this, notice they write it in function notation and they insert those values and simplify. So this is my f of x. So a, we'll say f of 2 equals 3 times 2 minus 2, which is 6 minus 2, which is 4. Now, let's see, do they rewrite it? No. So they just leave it at that. B, f of -2, so we have 3 times -2 minus 2, which is -6 minus 2 is -8. C, f of -4, we're inputting -4 in for x, so 3 times -4 minus 2 is -12 minus 2, -14. We don't have to write it in domain and range because they haven't asked for that. They just want to know what is the value. Find the value of each function with the set of real numbers as the domain. Okay, well, P let's do A, sorry, P of 1 equals 4 minus 2 times 1, which is 4 minus 2, which is 2. P of 0, 4 minus 2 times 0 is 4 minus 0 is 4. C, P of negative 2 is equal to 4 minus 2 times negative 2 equals, we're going to do orders of operations. We don't do the 4 minus 2, we do the multiplication. So negative 2 times negative 2 is positive 4. 4 plus 4 is 8. I'm going to write it as R of 2 equals, so we're going to plug in 2 for t because this is really R of t. So remember, this is R of t equals t plus 2. That's all that equation equates to. So I'm going to do the A part, sorry. R of 2 equals 2 plus 2, which equals 4. So functions can be really easy and fun and enjoyable and not intimidating or confusing. Confusing. Let me put my dentures back in. No, I don't have dentures. Number 18. So G of 0 equals 0 minus 3, which is negative 3. G of 2 equals 2 minus 3, which equals negative 1. G of negative 3 equals negative 3 minus 3, which is negative 6. Hopefully they start doing some operations. That would be cool. So you'll see operations here. So H of 3, oh, I forgot to do A, B, and C. Sorry, A, well, no, we'll just, H of 3 equals 2 times 3 squared plus 1. So orders of operations, we're going to do the squaring first. So 2 times 9 plus 1, which is 18 plus 1, which is 19. B is going to be H of negative 2. So that is 2 times negative 2 squared plus 1, which is 2 times 4 plus 1, which is 8 plus 1, which equals 9. C, H of 0 equals 2 times 0 squared plus 1, 2 times 0 plus 1, 0 plus 1, which equals 1. All right, we'll see. A, K of 4 equals 2 times 4 squared minus 3, 2 times 16 minus 3, which is 32 minus 3, which equals 29. B, my handwriting is getting poor. K of negative 2, switching legs. K of negative 2 equals 2 times negative 2 squared minus 3. Negative 2 squared is 4 minus 3, which is 8 minus 3, which is 5. K of negative 3 is 2 times negative 3 squared minus 3, which is 2 times 9. Negative 3 times negative 3 is positive 9. Then we do multiplication first, and then we get 15. That was a long 5 right there. All right. A, G of 4 equals 4 squared minus 1, which is 16 minus 1, which is 15. G of negative 4 equals the quantity negative 4 squared minus 1, which is also 16 minus 1, which is 15. And C, G of 0 is 0 squared minus 1, which is 0 minus 1, which is negative 1. Okay, Still within these, h of 2 equals 3 times 2 squared plus 1, 3 times 4 plus 1, 12 plus 1 is 13. We're at that point. Can you feel it? Where you're sort of getting tired of doing the same thing? That's okay. You need to understand that this is practice. And if you can consistently do it correct each time, then that looks good. That's a great test for your stamina to do long tests like the SAT, like the ACT, like the HSPT. And you want to make sure that you're not going to make any silly mistakes. So let's see. That looks good, and that looks correct. Yes, 1, 2, 3, 4, 5 more. And they didn't really get. So we would write that as r of y equals y cubed plus 2. So r of 0 equals 0 cubed plus 2. 0 cubed is 0, plus 2 is 2. R of negative 2, you need the quantity, plus 2. Now, any negative number to an odd exponent is going to produce a negative number. So that gives us negative 6. That's important to know. So here we have 2 cubed plus 2, which is the same thing as 8 plus 2, which is 10. That's good. We'll write it in function notation. N of t equals t cubed minus 8. N of 3 equals 3 cubed minus 8. 3 cubed is 27. You should know that. And we get 19. N to the negative 3, which is quantity negative 3 cubed, minus 8, which is negative 27. Odd exponent. Negative number to an odd keeps the negative. Minus 8 gives us negative 36. No, not 36. 7, 7, 14, 15, 35. I thought there was a 9 there. 35, 7, 14. Yeah, that's good. That one at least was right. And C, N of 0. They love their zeros. 0 cubed minus 8 is 0 minus 8, which is negative 8. Well, I guess we won't see functions multiplying each other. F of negative 2 equals the quantity negative 2 squared plus 2 times negative 2, which equals 4 minus 4, which equals 0. B, F of 2 equals 2 squared plus 2 times 2 equals 4 plus 4, which equals 8. And F of negative 1 equals 1 squared plus 2 times 1, which is 1 plus 2, which simplifies to 3. G of 3 equals 3 times 3 squared minus 2 times 3. We got to do exponents first, so that's 3 times 9. We can simplify that, minus 6. We're going to do 27 minus 6, which is 21. A lot more steps on that one, that's for sure. So 3 times 1 squared minus 2 times 1, which is 3 times 1 minus 2, which is 3 minus 2, which is 1. g of negative 1. This will be fun. 3 times the quantity negative 1 squared minus 2 times negative 1, which is 3 times 1. Notice a negative exponent to an even power ends up positive. And then we have negative 2 times negative 1, which is positive 2, which is 3 plus 2, which is 5. Last one. A p of 2 equals 2 minus 2 squared. Now, we're going to square because that negative is outside. The base of this exponent is y. It does not include the negative because there's no parentheses here. Important. This is a really good problem because a lot of students will get this wrong. And it's important for the notation, especially for C. It'll be interesting to see you do C. So 0 minus 0 squared, which is 0 minus 0, which is 0. That's not the hard one. Here's the good one. Let's make sure that we do the proper notation. Negative 2 minus the quantity negative 2 squared. So we're going to square negative 2, which is 4. So the negative, the 2, the minus, and then we square negative 2, which gave us the 4. So we get negative 6. That's really the big tricky one right there. Is the last one. Hope you did well on these. This is an important one. Function notation. You should definitely be familiar with functions by the time you leave Algebra 1.